So I'm guessing that you're here today at Thoughtworks because you're either a technology leader at the moment or an emerging technology leader, or you appreciate technology leadership. Would that be fair to say? Hands up, anybody? Yes. So what I'm going to share with you today is reflective of the fact that as we get more and more experience in organisations, as we get more and more leadership responsibilities, we move from working in the system to working on the system. So I can see some nods. I think people have a sense of that. So it's less about writing code, and it's increasingly about changing the system that you're writing the code within so that it's easier and more effective to write your code and to deploy out to prod. So I'm getting some nods, so I think there's some resonance here. This morning, for those of you who were here this morning, Ankit spoke about systems level thinking, system thinking, yep. And some of the things that he spoke about was thinking of the system, thinking of the whole rather than the parts of the system, and optimising for the whole. He also spoke about accommodating psychology as part of that and the culture of the organisation as part of that, as well as incremental changes. So a plan, do, act, test sort of approach, as well as considering system level changes. So he presented that this morning in terms of the framework and advocating for that type of thinking. What I'm going to share with you today are some really pragmatic ways that you can do that as leaders in your organisations. I've been doing this sort of work for the past 10 years at Thoughtworks. I'm from Melbourne. I've come here to Singapore to share my experiences with working this way with you all, and I'm hopeful that in hearing some of these stories, you can perhaps learn some tools and take them back into your organisations as well, so that you can change the systems that you work within as well. So let's see if this works. Yes. So we talk about debugging engineering organisations, and the nature of that is that there are organisational bugs. And here is a selection of organisational bugs that you might relate to. When the website crashed, we needed 4 days to identify and resolve the problem. Hopefully no one's experienced this, but this is one that we heard from a client recently. We have no way of knowing what data our APIs are exposing externally. I'm not going to ask you if you have heard this one before. Hopefully you haven't, but it's not uncommon. The platform team doesn't have the capacity, so we'll just build it ourselves. This is super, super common. Yeah, I'm guessing a lot of people can resonate with that one. We love our annual hackathon. It's a great way to actually get things done around here because we can bypass the process. I can see some smiles. I think there's some people that have done this in the room. So these are all signals of organisational bugs where people are unhappy with some part of the system and they're trying to work within the system with these challenges, really. So I would ask you to think as I go through this presentation, what's an organisational bug that you experience in your workplace that really annoys you? Just spend some moment. It's usually the first thing that comes to mind because it's the most annoying. So just think about that and hold on to that as I go through the steps that I'll talk you through today. And hopefully you'll be able to match some of the things that I'm doing with some actions that you might take. So first of all, let's talk about the metaphor of debugging. And the reason that we created this metaphor for working at system level was because we work with technology, people in technology all the time, and it's often really common for people to feel that they can't change the system, that we're stuck in the middle of it, it affects us, we don't affect the system. And I think as Ankit talked about this morning, it's always about us in the system. We are of the system, we work with and we influence the system. So in being in the system, we are debugging the system, and we can debug the system in the same way that we debug our code. So in working with a code base as a system and debugging a code base, think of that at an organisational level, where you're debugging an organisation, because an organisation is just a system in the same way. So why think about debugging an organisation? Because similar to debugging, sometimes the problems can be abstract and they can be hard to own because of the complexity and the challenges of understanding who created that part of the system and when they created it. It's hard to find data to validate the problem. If you've ever debugged software, you can resonate with this one. Sometimes it can be really hard to find where the root cause of the problem is. Exactly the same with an organisational system. I can't tell the amount of times where I've talked to people about organisational challenges and they've said, I have no idea who's responsible for that or who I would even talk to try and resolve for that. So that's demonstrating this part of that metaphor. We often make people the problem rather than the systems. This goes back to, I think, what Ankit was saying earlier today. Because people are in and of the system, we tend to say, well, it's that person's fault or it's that team's fault or it's that division's fault, instead of thinking of it as a system as a whole and abstracting it. And then finally, when we're looking at organisations, it's really hard to test them in the way that we can test code, right? We know that we can set up test harnesses, etc., for our code bases. How do we do that when we're trying to change systems? So what I'll do today is talk you through addressing some of these challenges in a way that is more data-driven, in a way that is more depersonalised, so that we're not, saying that people are the causes of the problem and have to solve the problem, as well as being an iterative solution. Just a disclaimer on using this metaphor, it can suggest that the problems are not of systems, or not of people rather, and the fact is that organisations are made up of and for people. Of course, people are part of everything that we do in organisations as systems and a critical part of it, but often we can get caught up in that a bit too deeply rather than thinking of things as a system and as a system level problem. So, in software, we understand that a bug is a design defect in an engineering system that causes an undesired result. Software development can be very abstract and conceptual, and we use higher order languages so that we can limit our cognitive load and deal with the layers and the complexity of the software. That means that defects can be super tricky to spot and to solve for, as well as being able to reason about and understand why they're there and how to solve for them. And organisations are exactly the same. They're complex adaptive systems. We add additional complexity into those systems every time we grow the organisation. And so to cut through that complexity, we have found, or we've designed a model that we think might be helpful, which we call the double debugging loop. So it looks a bit like this, which uncomfortably looks a bit like an eyeball, but let's back away from that one. So why I say it's a double debugging loop, and it goes to what I was saying earlier about being being part of the system and working in the system as well as working on the system. The inner loop is your job that you undertake as a leader at the moment, or as an engineer in a team where you're actually working in the system. The outer loop is where you're actually taking a step back and working on the system. Exactly the same steps, but you're working with a different boundary, if you like, whereas the inner loop is the work that you do as part of your job as managers now. The outer loop, at a system level, requires you to work with people outside your specific areas of accountability and work with your peers or work with other divisions in the organisation to enact that change. So we'll spend most of our time in the outer, well, all of our time really in the outer loop, because that's about the system level change that we're talking about. There's 4 parts or 4 steps really to debugging an engineering organisation that we're proposing. I'll start over here, which is about where the flow starts, if you like, which is often where you get a trigger event for debugging a system. This might be a new leader starts, so a new CTO might start in the organisation, or a CEO might start in the organisation. It could be a compliance change from a regulatory perspective where they've said this needs to change about your organisation and you need to enact that. That's a trigger. It could be a security outage that you need to address. All of these things can be trigger events. Part of the flow is to gain permission to solve that event. When you're working with the system, you can't just go off alone and do it on your own. You actually need to engage people to get permission to solve for this problem. And then after that, you're prioritising. You're prioritising whether it's an internal one that you can control, in which order of priority you should address it against all of the other work that you're dealing with. At the system level, it's all of the other work that is happening at the system level and whether this is the most important thing to solve for now. So the 4 steps, first is about surfacing the bug. In this case, you're creating an awareness of the fact that there's a challenge in the system that is of the system and that you're wanting to solve for this. The second part is about diagnosing, where you're looking at the root cause of the system bug. The third is about designing and testing a fix. And then the fourth is about deploying and measuring the impact of the fix that you've rolled out in the organisation. So here are some examples of things that might fall into the inner and the outer loop. From an inner loop perspective, the things that you can control potentially is about your own priorities and your own WIP limits. You might be able to control how your teams are shaped if you're an engineering manager, what capabilities that you have in the teams. My technical debt is getting out of hand. This is material both to engineers writing their own code, as well as teams, as well as organisations. And then at the outer loop, at a system level, way too much work for the capacity. So the business stakeholders have funded all of these initiatives at the start of the financial year, and they're trying to get us all to do it at once. There's just not enough capacity to deliver all of that work. I'm not sure if the work that the teams are doing is a strategic priority. How do we make sure that this is the most important work of the organisation? Our organisations are so complex we can't get anything done. And finally, our initiative structure for engineers leads to too much WIP. So all of these examples on the outside are more strategic outer loop problems that require engagement with stakeholders outside of your own area to work with. Do people resonate with these? Can you think of examples where you've seen some of these inner loop and outer loop problems? Yep. So, how do we diagnose and fix design defects across these abstractions? So let's now enter that outer loop and go into detail about those 4 steps. So the first is about surfacing the bug. Every organisation is a complex adaptive system. Lots of different factors and subsystems are at play, and most of all, the people element introduces a level of variability that is really hard to predict or manage, really. And so how do you surface the bug and prepare a debug environment, if you like, in a way that you can work with? And so the key is to work with other people to do this. And the first is about depersonalising the problem. So understanding that this is a problem of the system. This is not a problem of somebody that didn't know enough and made a wrong decision. This is actually a problem of the system caused by the system, and let's treat it like that. The second is to use the prime directive. Hopefully many of you are familiar with the prime directive, which says that we believe that the actions and the decisions that got us to this place was made with the knowledge and the information that we had at the time, and we have to believe that they were making the right decision that they thought at the time. So we don't blame them for that, we just work with what we have and move forward from here. Using the prime directive means that you can move forward positively rather than pointing the finger and affecting blame at the start of this, which is again about depersonalising it. And then thirdly, it's about collecting problem data collaboratively, like working with your peers, working with people across the organisation to try and surface some of this problem data and get a collective appreciation for the bug that exists in the organisation. So a top tip for surfacing the bug is about getting permission to solve for this. We did an assessment with an organisation where the product organisation had asked us to come in and help them understand why the technology teams were so slow. Not an uncommon accusation that's made about technology teams. What we found is that one of the key reasons why technology was so slow is because they were creating lots and lots of products and the business would not let them decommission any of them. So when we played this back to the business stakeholders and said, actually, your inability to decommission these products is one of the reasons why the technology teams are consumed with all of this operational debt, they didn't take that very well. In that context, we didn't have permission, actually, to solve for a business problem. She needed to hear that it was a technology problem and was not appreciative of the fact that we diagnosed the root cause of a problem actually in the business space. So when you're working with surface level problems, be very mindful of the permission that you have to solve for the root cause and what kind of engagement that might result in with different stakeholders. Okay, so the second step on the loop, on the outer loop, is about diagnosing the root cause of this problem. It's really rare for a system level problem to be just part of one system. What we've got here in this diagram is an encapsulation of the many different subsystems that can exist in organisations. In smaller organisations, these can exist in 1, 2 or 3 people. In larger, more complex organisations, you can have whole departments for each of these subsystems. And working out where the root cause of the bug is across these systems can be really very complex. and needs often engagement with a broad set of stakeholders to understand where it might be from. Often systemic challenges are behavioural rather than structural, which means that they can actually be embedded in the culture rather than any organisational boundary like this. Often, you might get this, but you can also get organisations that look a little bit like that. They don't have clear boundaries. Everything is just mixed in together. You know, this is the reality of modern organisational evolution, right? We're going to market at pace, and we're not necessarily working within our boundaries. So it can be a bit like going through the dirty washing when you're looking for system level bugs. And so it's good to have an appreciation for that. So how do you diagnose with the complexity of subsystems? So here are some example tools, and I'm not going to go through them all because there's a big long list of them. Here are some example tools that we use for framing, for inspecting, for mapping, and for doing technical deep dives when we're trying to understand a system, when we're trying to really locate where the root cause of a problem is. I'll just spend a couple of minutes on two of my particular favourite ones that I use. Are you recognising some of them? So two of the ones that we use that are really very impactful to help people see across the system. One of them is value stream mapping, which is where you're looking at an end-to-end process. You're mapping the inputs and the outputs of every stage in that process, and you're also accounting for, or you're mapping the cycle time for each of those processes and who's involved. So I can give you a really good sense of where the wait times in a process are in the organisation and why that might be. It's almost like visualising breakpoints in the organisation. In this example, we did the flow from idea to ready for dev, and then underneath that we did from dev done to live in prod, and to try and work out where some of the organisational flow challenges were. In this example down the bottom, it's a Wardley map. If you haven't seen it, it's open source technology. It's open source methodology. And it's really helpful to visualise the maturity of all of the parts of technology or even divisions in a system. And I've used this really effectively, particularly at executive levels who don't know and don't want to know the complexity of the tech stack, but need to understand where it might be stuck at a system level and why. And so Wardley mapping I found is really helpful for that. So a top tip when you're diagnosing is collaboration. Again, it's about not scapegoating. It's about making sure that you've got a really good contribution for people across the organisation to provide data into diagnosing and identifying the root cause for these. Now, an example of this, which is the anti-pattern for this really, I ran a workshop with a group of technology executives in a bank, and we were looking at the systemic challenges that they were experiencing and trying to prioritise them so that we could work on them. And we ran a workshop and we got them to put sticky notes on the wall for all the problems that they saw in their space that they were working with. And then when we stood back and looked at them all of them were in teams outside of technology. It was as if technology was angelic and pure, and there was nothing at all wrong with technology. All of the problems in the organisation were outside of technology, which is a really, really common thing to do. No one likes to feel that they're part of the problem. We all want to feel like we're part of the solution. But it's a really natural habit to try and, even unconsciously, protect ourselves from that by locating the problem elsewhere, which is all about scapegoating. So by collaborating and getting collective data, you can help to avoid that anti-pattern. So the third stop along our journey of the outer loop is about designing and testing a fix. And this is where the plan, do, check, act model can come in. This is where you're looking at really doing something as a pilot or something at a small scale that can test a fix that can scale for the whole system. What I've used with this effectively is used a hypothesis-driven approach where you're looking to isolate something in a small way that can test what you're looking to introduce across the system. And in this instance, the hypothesis I used was about an operating model. So it was about having persistent cross-functional value-oriented delivery teams with end-to-end accountability for outcomes. And we said that if we did this, we'll deliver greater value for customers over time. And there were metrics that we applied. We will know that this is true when we see value being delivered, etc. And we'll know it's it's false, like the hypothesis, pilots, tests need to be able to fail so that we can learn. We know it's false when we see X, Y, and Z. And so by framing the system intervention or the system change with a hypothesis, it gave us permission to fail, actually, and it gave the organisation permission to learn, and appreciating that there's a lot of uncertainty in the system that we don't know about when we start these things, but by moving into it, we can give ourselves a chance to learn what those things might be. So by framing a change as a hypothesis can give you an edge, really, in introducing system change, because you can also design a hypothesis to test the scale levers that you need to use, whether it's testing user adoption or testing pushback from different teams that you might expect. You can frame that as a hypothesis and actively look for it. Some of the tools that we use to design and test a fix are represented on here. They're ranged according to the invasiveness in the organisation and where they apply to either existing teams and to new teams. So where you're testing a fix, you can go big bang. That's probably our least recommended option of implementing a system fix. You can use a pilot team, you can use change agents, you can outsource to get different capabilities into the organisation. You can do training, augmentation, proof of concept, steel threads. Steel thread is a really good intervention that we recommend. It's where you bring together a cross-functional team across the whole system and you get them to work on a problem. It might be a hello world type model through multiple systems, so that you're testing what the stress points are through each of those systems. We did one with an insurance organisation where we had to bring many systems together to see what we needed to do, which systems we needed to interact with to create a new policy. And it gives you a very nice short test for a larger system fix. Top tip in testing these changes, it's about working with the change capacity of the organisation. I think everybody would agree. I'm actually really pleased that you've got time off work to be here today, because often it's actually really hard even to get one day off work because there's so much pressure on all of the work that we all have to do all of the time. Because there's so much pressure, it's hard to get capacity to actually accept change. And it's really helpful to frame change as needing capacity on the team in the same way that a feature does, in the same way that anything else does. It will take up capacity. It does need to be prepared for, and you need to work within that. We had multiple changes happening in an organisation we worked with, and we found that we were hitting the same people. And so we had some people participating in a stream and they just dropped out as soon as we introduced this new change. People have a natural change level that they can absorb, and it's important to be respectful of that. And then the final point of the outer loop is about deploying and measuring the fix, the system level fix that you've deployed. Often, when you're talking about system level change, it requires investment from your organisation. Investment of either time and money, usually both. When you're dealing with executives about system level change, these are the 4 things that they will care about. They will care if this change helps them grow revenue, if it helps them to protect revenue, if it helps them to avoid costs, for example, avoiding a compliance cost, or if it helps them to reduce cost. So, for example, we're getting more value out of our technology sooner. Most executives in an economically difficult time will only focus on the top 2. Really, they will not invest in things that do not materially demonstrate revenue growth or revenue protection. So if you're able to anchor your system change to revenue growth or revenue protection, you'll have a lot more chance of getting it invested in by your stakeholders, your organisational stakeholders. When you're doing that, make sure that you're thinking about providing a measurable return. So this is the ROI for the investment that you're making in the system. It might be about retention rates, it might be about revenue, traffic, cycle time. For example, you can use qualitative surveys to get those metrics to demonstrate an ROI. For example, if it's a cultural change where you're looking to increase employee engagement. Number of projects in flight is an example of work in progress change measures. And then system uptime is always a good one if that's what the fix is related to. And finally, on this last fourth one is the top tip: aiming for no surprises. drawn again from hard-learned lessons. We spent a lot of time designing a system change, and we visualised the system change, and we brought the executive in to the room to see the change that we had prepared, and he took one look at the volume of work that we had visualised and basically turned around and walked away. And we never got him back. And so because we hadn't prepared him for what we were going to show him, it was too much of a surprise. And all he saw, and this is a banker that managed millions of dollars of the investment slate, all he could see was that we were potentially asking him to make decisions about this wall of work that he really didn't know anything about, and he couldn't make decisions about this. And so the overwhelming nature of the information that we were sharing was way too much for him to absorb. So bring people to the problem gradually, aim for no surprises. And then when you finish the loop, you get to start again, because a system constraint is never gone. The constraints in a system just move to another part of the system. There will always be a system level bug that you can be addressing, that you can be working with. And so, yeah, once you've finished, you get to start the next system level bug to work on. So while you're moving around the loop, be mindful of those 4 points. Get permission, collaborate while you're doing it. Don't do everything all at once. Be mindful of the change capacity in the organisation, and aim for no surprises. So I asked you at the start, what's the organisational bug that annoys you the most? So hopefully, based on what I've shared with you, you have some ideas for how you might start to resolve that. And so my question for you to think about is, who will you start speaking with tomorrow about starting to fix that organisational bug? Thank you, and happy debugging.